Hello everyone. Today we are going to learn the continuous random variables. Continuous data occur when the variable of interest can take on any one of infinite number values over some interval on real line. A probability density function. So f of x, as you know, the capital X here, because the capital X represents the random variable, f of x is a smooth curve that represents the probability distribution of a continuous random variable. So generally the shape is like this, okay? And on the y-axis we have the f of x, on the x-axis we have the values of x. And in our calculations you are going to see this kind of shaded areas. So it can be upper area between these two areas or the lower area. But this kind of shaded area can be represented as this. Probability of x between these two values. As you see, the probability of x is the continuous random variable, between these two values can be shown here. Probability of x1 less than x less than x2. Be careful, the x is the continuous random variable, but x1 and x2, these are the boundaries, lower boundary and upper boundary. So we are going to calculate this kind of probabilities, okay? And in our calculation, the most important thing is the total area. The total area under the curve is 1. Since it's a probability distribution, 1 means 100%, as you know. So don't forget, the total area, I'm not talking about the shaded area, I'm talking about the whole area under the curve is 1. And our target is finding the shaded area, okay? Okay, the next step, we are going to learn the normal probability distribution. So the normal probability distribution is a symmetric bell-shaped curve. So what is the important point here is, so the symmetric is important here, the symmetrism. So as you see, the middle or the center is the mu. As you know, mu is the population mean. On the x-axis we have the values of x. On the y-axis again we have the f of x. Okay, so as you see, it's a symmetric. As you see, the left side, right side is a symmetric curve, and the center is the mean. So the most important thing here is we have the special symbols for showing the normal probability distribution. So it's here. So this bell-shaped curve, this normal probability distribution is always shown like this. So you have to show that x is the random variable, continuous random variable. This sign means x is distributed normally with a given population mean and given standard deviation. One more time, x is distributed normally with this given mu and this given standard deviation. Okay, so for example, if you see something like this, x is distributed normally, let's say 3 and 5, this means that let's say 13 and 5, this means that the first one, which is the 13, is the mu is the population mean. So the population mean is 13 and 5 represents the standard deviation, so it is 5. So x is distributed normally with a given population mean of 13 and a given standard deviation of 5. Okay? Okay, as you see here, this curve is usually referred to as the normal curve. And the actual formula for the probability density here is f of x equals to 1 over in the square root 2 pi times standard deviation, which is sigma, times e to the power negative in the big parenthesis x minus mu square, close the parenthesis, divided by 2 sigma square, where e is the constant number, which is 2.718. This number is stored in your calculators, and pi is again 3.142. This is also stored in your calculators. These are the standard numbers. It's a fixed number. These are the fixed numbers. And mu is the, again, population mean, and sigma is the population standard deviation. I know that the whole formula, which represents this curve, looks weird, but the good news here is I'm going to teach you more stuff so that you are not supposed to use this strange formula in your calculations. Okay, I'm just giving you this for the reference. So this curve is shown like here. X is distributed normal with a given mu and given sigma. Okay, and this f of x, the whole thing, the curve, can be represented from here. F of x equals to 1 over 2 pi in the square root times sigma times e to the power negative x minus mu square divided by 2 sigma square. You are not supposed to memorize this formula. However, you have to learn this format. Okay, this format means the first, whatever you see in the parentheses, the first one, the first variable is the mu, the second variable is the standard deviation. Okay, in the next step, let me give you some properties of the normal distribution. As you see, as I told you, a normal distribution is fully described by its two parameters, mu and sigma. That is, once the values of these two parameters are known, one can find out the probability of x lying between these two numbers, okay, or within a certain interval from the mathematical formula given before. However, these probabilities can be easily obtained from the specially prepared table, which is known as the standard normal table. So in the next step, I'm going to show you the standard normal table and standard normal distribution. But let me finish the normal probability distribution's properties. As you see, these two parameters must be given. Otherwise, we cannot specify the normal distribution. And in the center, we have the population mean, and this is a symmetric bell-shaped curve. And the next thing here is, this is the next thing. As a matter of fact, approximately 68% of the area under the curve, under the normal curve, lies between mu minus sigma, mu plus sigma. So within one standard deviation, one more time, within one standard deviation in both sides, you can add one standard deviation, or you can go on the other side, means mu minus sigma. It covers like approximately 68% of the total area. And if you go in both ways, like 2 sigma, if you add 2 sigma to the mu, or if you deduct 2 sigma from the mu, in both ways, you are covering 95% of the area. Okay? And in 3 sigma distance area, okay, you are covering the 99.7% of the area under the curve. So we can say that, like, in three standard deviation distance, means like you can add 3 standard deviation to the mu, or you can go on the other side to the 3 standard deviation. You are covering 99.7% of the whole data. So we are going to use this kind of important informations in our calculations.